Thank you.
In the dormitory, poke an all-terrain supersonic missile vehicle. This method is simple. Use a direct current gear motor set, apply a little force, and it stops due to insufficient torque. Steal a high-power one, remove the reduction module, and knock in a gear connector. It's not suitable, so directly drill to enlarge the hole. Now it should be fine. Tighten the screws and try again. No problem. Almost ran to the trash can to pick up a piece of scrap metal. Found 4 strips with the shear, cleaned them, then went to the front of the stage to fold them into right angles and started welding. This is the central frame of the small car. Start drilling on the side, a large hole for securing the gear reducer motor. Be sure to tighten the screws. Hammer 2 bearings onto a connector and weld it to the frame. On the other side, make another set with 4 rotating shafts. Insert the drive gears, measure the length, install the chain, drill 2 positioning holes on the frame, and use a power drill to go through them. Be very careful not to damage the motor. Fix one side of the hinge with screws, pass the axle through, weld fixed panels on both sides for future support of the lifting chassis. Use suitable lengths of metal pieces to connect the joints on both sides to the center of the frame, fixing the axle components and connecting them to the transmission arms on both sides. Install the phantom bracket. The movement is very smooth. Use a threaded rod to connect the lifting motor fixed on the frame as the power output of the lifting drive wheel. Continue to cut some long strips of metal. This time directly punch some positioning holes. If it won't drill, just use a punch. It's faster and more efficient. Fix 4 pieces as a set on the connecting plate. Cut 2 sets of finished off-road 4-wheel kits and use screws to connect. Cut spring assemblies and attach them to 4 wheels. Test the chassis lifting system. Not bad, not bad. Let's test the weight capacity with an iron block. The power is very strong indeed. After 3 millimeters, drill 1 big hole and 4 small ones in the iron plate. Be careful not to cause any damage. Drill 2 more below to complete the right angle connection. Knock on the nearby motor transmission gear and weld it for extra strength. Align the holes and fix with screws. Place the gear on the shaft, drill a hole at the end, insert a fixing pin, put on a nut, and weld directly onto the frame. Secure the transmission gear as well, and start it up to test the power. Not bad, not bad. The speed is very fast. This is the power source for the 4 tires. The small metal pieces are hammered into a U-shape, connected and fixed, burnt and clamped. Then another U-shaped piece is attached to form a universal joint combination, welded with square tubes and used together.
The
transmission arm connects to the rear axle accelerator. Perform the same operation on the other side. Fix 2 blocking plates on the front axle at the right distance to connect a 4-volt motor for controlling the vehicle's steering. Fix the track wheel assembly by directly tapping it into the frame. Install the tank track. The size of the finished product is just right. Let's test it in the desert. When encountering dunes, the wheels lose traction, so next, activate the tracks. Not bad, not bad. The chassis lift system is excellent. The car smoothly climbed the dune. The power is amazing. However, the rubber tracks got too much sand in them. So replace the part supporting the sand directly.
Since the company's
Do not install the transmission gear. Be sure to fasten it tightly to prevent it from coming loose. Removed a bicycle chain and cut small iron squares directly welded to both ends of the chain to increase friction with the ground. Although the workload is a bit large, the finished product is indeed quite impressive. It greatly enhances the wasteland style. Performing a spot turn for the viewers. Next, begin installing the car body part. Weld a sleeve and knock in a bearing. Connect the central shaft and transmission gear. Weld them onto the rear frame. Connect the gear to the speed reduction motor. Adjust the angle. Weld it next to the gear. And ensure normal operation with electricity. Can't hold it with hands? Continue welding the shell. Snap on the cover. Screw it on. Squeeze to connect the drive shaft extension plate. Make another frame. Fix the small motor. Use a screw rod and nut for transmission. Connect the fixing piece. Install a long rotating shaft. Tighten both sides. Parallel weld 3 cannon barrels. And use the drive motor for a test. No problem, it's just that the wire for the rotating part is short, so it can only turn 360 degrees. The missile launch module must be securely installed. Next, start assembling the cockpit. Each part needs to be seamlessly welded. The threaded holes on the front part are used to install the headlights. Install the frameless glass for the door as well. And finally, the ammo box with some scrap charcoal as necessary. Next, start painting. Make sure to paint each part evenly. Apply some camouflage paint since it's a military vehicle, right? Okay. Our all-terrain missile vehicle is now complete. The small lights are really bright, and there's even a high beam. Next is the all-terrain test that everyone's been eagerly anticipating. First is the 4-wheel driving on standard roads. This certainly works flawlessly. With some acceleration and differential on all 4 wheels, on flat ground, is definitely the king. Reversing is also very smooth. Next is the desert terrain test. A sand dune appears ahead. Oops, got stuck. Back up and charge again. As expected, it still doesn't work. Next, activate combat mode. So handsome.
Pass easily.
Friends who have watched this far, please tap the screen and then send a rocket to everyone. How about it? Do you love this little thing now?